Now in numbers 7 and 8, they don't give us a graph. So we have to come up with this graph first and then find the points of intersection. And then after we find the points of intersection, we know what our limits of integration will be. So in number 7, we have a sine wave. Okay, we have a sine wave here, and looks something like this. And then we have another function of 1 minus x squared. 1 minus x squared. Now 1 minus x squared is going to look something like this. So we're looking for the area between these two curves. So we have our upper function, which is 1 minus x squared. Then we have our lower function, which is sine of x. We're trying to find the area between those two curves. So we need this point, and we need that point. And then when we write our integral, it's going to be 1 minus x squared minus sine of x. And we just need to know these 2 points. So we have our limits of integration. So I'm going to take y is equal to, and that would be my upper function, 1 minus x squared, and my lower function is sine of x. Now, just to be sure, make sure that you are in radian mode. So I'm going to change my window. I'm going to go from -3 to 3, -2 to 2. If you remember, in terms of amplitude, the amplitude of that sine wave is 1, so we don't have to go much more. Well, it will fit from -2 to 2. But then notice when I graph this, I can see the point of intersection here, and then I can find that point of intersection there. So first one I'm going to find is in the third quadrant. So my negative value for x. So second trace, intersect, and I'm going to give it a guess of -1. And when I do that, I come up with -1 point, so -1.40962. Now I need to get that other point. So second trace, 5, and then my first curve, my second curve, and then I'm going to give it a guess of, let's say, 0.5. And when I do that, my point of intersection here is 0.6367. So 0.6367. And now I have my limits of integration. 0.6367 and -1.40962. And the nice thing about this is when I've set this up, I know that y1 is my upper function and y2 is my lower function. So I don't have to type these in again. I'm just going to use math 9, so f and int. Then I have my upper function, which is y1, minus y2, and then comma x, and then I just put in my limits of integration. So -1.40962 and 0.6367, and then when I integrate here, I get about 1.6070. So the value of this integral is 1.670 to 3 places. That's what I'm looking for. Now in number 8, we have one function which is cosine of 2x, and our other function which is x squared minus 2. Now when I graph this, it's a cosine wave that has been shrunk. It's been actually compressed horizontally here. So cosine of 2x is going to look something like this. Okay, and then x squared minus 2 is going to look something like this. So if we graph it, let's see what we get here. We have the cosine of 2x, and then I have x squared minus 2, and graph it and see what it looks like. Looks pretty close so far. And there we go. Now, what we could do is integrate from this x value to that x value. But if you notice, it is symmetric with respect to the y-axis. So what I'm going to do is just integrate from 0 to this point and then double it. So I'm going to integrate from here to there and then double it. So when I set up my integral, it would be cosine of 2x minus x squared minus 2 with respect to x, and then 0 to my point here, and then I'm going to double that. Now again, you don't have to do this. You can integrate from this point to that point, but these x values, whatever this one will be its opposite. You can double check that. Let's do second trace, 5, enter, enter. I'm going to give it a guess, let's say 2, and when I get this value, it turns out to be 1.15296. So this is 1.15296, and now I'm going to do math 9, F and INT, and again I have my upper minus my lower all set up. So upper minus lower with respect to x, and then I'm going to go from 0 to let's see, 1.15296, comma, let's see, there, and then I'm going to multiply it by 2, and I get about 4.332. So 4.332. And so there you have numbers 7 and 8.